interrupt if you want me to repeat something. So to get started, we're going to duplicate this project. So we always want to, if we're adding new things, we always want to duplicate or make a new copy of the project. So that way we don't overwrite the previous version. For some reason it's not letting me do that. I'm going to try reloading this. Okay, there we go. So when you duplicate, it'll change the name. It'll add copy at the end of it. I'm not sure why it didn't do it the first time. Maybe it did and it just took a while, but you can see the copy there. So I'm just going to rename this. And so this lesson is on objects. And we're going to add a bird object. And we're also going to turn our player into an object. So I'm going to update this comment here, adding objects. And I'm going to delete some of these comments from the previous lesson just to clean things up a little bit. Okay. What we're going to do is organize our code into different objects. We can see how Scratch does that by default. In the Scratch editor, you have different sprites, and the sprites are connected to blocks of code, and that's how we organize our code. JavaScript is designed to work the same way. This is part of a general programming paradigm called object-oriented programming. It's one of the sort of principal programming paradigms that you'll work with. It's not necessarily the best one. There's different programming languages that use it, and there's some that don't. But most of the modern programming languages like C++ and Python and JavaScript use object-oriented programming. Basically, what object-oriented means is similar to how Scratch is designed. Scratch is designed so that you add objects into the game, like sprites, and then there's properties that are associated with that object, like the name of the sprite, the X and Y position, the size, direction, the costumes and the sounds that are associated with the sprite, and then the functionality of the sprite that is designed with the code. So in JavaScript, when we create objects, we're doing very much the same thing, but we have to do a lot of the extra work to actually create the object and define what it is that Scratch kind of does for us. So in JavaScript, the way that we create objects is using functions. So far, we've used functions for things like our main components of our code, like the preloading our media, setting up our canvas, drawing our graphics. All of these functions are kind of like handling the main components of our game. But when we want to create objects, we also use functions, and these functions have a slightly different naming convention. And we'll look at what that looks like. But the main thing that we want to do is organize some parts of our code into a new function. And some parts of our code we're going to leave in the main code block. And part of the trick is knowing which parts need to be part of the function and which parts don't. So when we think about how our program works, we can think about what's in it. So we have our game window, and we have our character, we have the bird that's going to be flying down on the screen. And so anything that is going to have its own XY value, its own animation, that is something that we want to organize into an object. And so instead of having like these global variables like we have here, let x and y, and our animation state, instead of having those in the global scope so that the whole program sees them, what we're going to do is put them into a function scope. So that's, again, it's like in Scratch when we're inside of the player and we go to the variables section and we make a variable. You can make a variable for all sprites or for just this sprite. So it's a similar thing in P5 or JavaScript. When we make a variable up here, it's accessible to all of the functions in the program. But when we create an object, it's going to have its own variables that only it has access to. So that way, the x and y values for the player don't interrupt the x and y values for the sprite. So just like in Scratch, again, our player has its own x position and y position. And if we change the x and y position of the player, it doesn't affect anything else in the program. We need to do something similar in JavaScript. So we need to kind of reorganize the code we have already before we can make it more complex by adding other objects. So it doesn't really matter where we put the object. I'm going to put it sort of towards the bottom of the code. And as our code gets more complex, something that's going to make it easier to read is what's called collapsing or folding our functions. So there's a little arrow next to the numbers for these functions. If you don't see it, you may have an error, so you might want to do some debugging or tidy code. But collapsing those functions is going to make it a little bit easier to read everything. So I'm going to go below the draw function. I'm going to leave this save image thing down here. I'll make a little space down here. So I'm going to make a new function. So this is the player object. And when I make a function that I'm going to use as an object, I use a capital letter at the beginning. This is just a naming convention. It doesn't change the functionality, but it makes it easier for other developers to understand the purpose of the code. So objects have capital letters. So I'm going to say function player. And just like my other functions, I'm going to have a parentheses, and then I'm going to have some curly brackets like that. So pretty much looks like all of my other functions. The only difference is that it starts with a capital P. There's going to be some other differences later, but for now, that's the only difference. And this should be on the global scope with my main functions like preload and setup and draw. So first thing we're going to do is we're going to take the values that we need to draw the player and move them into our player function. So we'll just start with x and y. So I'm just going to cut those and paste them into the player. So these are called member variables. These are variables that are part of a function, and they're only going to exist inside that function. So only exist in player function. And these are also our player properties. So the position and the animation state, you might have other properties in a more complex game, but we're going to stick with those. So these are our object properties. So we have the position is x and y, and then we have our animation values. So for my animation, I'm just going to grab this animation state and just leave the comment here. And I'll get rid of this comment up here. So at this point, you might think that I want to include my sprite values in the player since they're related to the player. But this process of loading the media is not just for our player object, so we want to leave those alone. We don't want to load different images. If you had multiple players for some reason, you wouldn't want to load the images twice. So anything that has to do with loading media or setting things up, we probably don't want to have in our player object. So I'm just going to put a note here. Leave media variables in global scope. Okay. So far, that's pretty good. We've got this little player guy. And now what we want to do, this is where it starts to get a little more complicated. Sometimes functions have their own functions. And that's where the programming gets more abstract. But it's still similar to what we saw in Scratch. So we can think of our different sprites as objects. And they have properties, again, like the name, position, all that stuff. And they also, they also have their own code. So when we look at our blocks of code, these are like the functions that are part of that object. So our player needs to do two things. It needs to move, and it needs to be displayed in the canvas. So I'm going to make a couple different functions. And then right now, the player code is all kind of in the draw loop. But what we're going to do is we're going to replace those two main functions or things that happen with two functions inside of our player object. So one function is we're going to move the player. Sometimes in a game engine, you'll see this referred to as update. So update or move, either one of those is fine. We're going to call this move. And then we also have the function to display the character. Again, this is just how we're designing the program. Some programs will be designed differently. They might squeeze those things together. It kind of depends on how your program works. But these are the two main functions that we want to display the character and move the character. Sometimes you'll also see this called draw. I like to avoid using draw here just because we have this draw function here. That's kind of like the main draw function. So that way it's a little less confusing. Although draw is nice because it's shorter. So, again, either way you want to call it. And then we have to do something that's a little bit different at the end of our function, which is we have to make some parts of the function available to the rest of the program. So the way that we do this is we use what's called a return statement. Return basically kind of sends certain parts of our program back to the main program. And so what we're going to return is our move function and our display function. And so this is pretty simple. We just name the functions that we want to return to the global program, and then we just put a little semicolon there. So you can start to see that this whole player object is starting to look like its own P5 program, right? It has its own functions, it has its own variables. It's like a little mini program inside of a larger program. So our program is getting a little more complex, it's getting a little more abstract, but it's going to allow us to add our bird object and make the game a little bit more dynamic. So let's move our code into those functions. So the first part is the movement code. So that's all of this code. It sets the animation state because the animation state depends on what movement is currently happening. So it starts by setting the animation, then it checks for input from the user and changes the position and the animation state depending on that input. So this whole section of code is my move function. So I'm going to cut. You could also copy if you're worried about losing it, but I'm just going to hit Command X and cut this and paste it inside the move function. Okay, so it's getting more complicated now. Remember to use tidy code to make things line up evenly. And there we have our move function. I can also collapse functions inside of functions. So I can collapse that move function if I want to make it a little easier to see. So then my display function is going to draw the character. So my display function is just this code. So I'm going to do the same thing. I'm going to cut this, and I'm going to move it down here. And I'm going to hit Edit Tidy Code again. Okay. So far we haven't actually changed anything. We've just kind of made our program more complicated by moving things around a little bit. But you'll see why in a moment when we add the birds, how this makes things a lot easier to organize. Okay, so now when I run my program, nothing's going to happen because I don't have a player. I just have a definition of a player. So that's an important thing with our object. we just have a definition of what an object is. We haven't actually created an object. This is also different from Scratch. When you create an object, when you make a sprite in Scratch, it just already exists. This is more like when we clone the bird. So in Scratch, we have one bird, but since we wanted more birds, we cloned the birds. And in JavaScript, when we make an object, we actually have to create the object. So it's like we're cloning it, but we're cloning the original one. So again, this is a little bit different than in Scratch. Scratch does it for us. But in JavaScript, we have a little more control over how this works. So I'm going to collapse this whole function. And what we're going to do is we're going to make some new global variables that we're going to use to create the player. So I'm going to say let player. And this is just equal to capital P player. So this just makes our player function. And remember, at the very end, this return statement, this gets returned to this variable. So if we make our player function, and then I log the player, if I say console.log player, if I run that code, nothing's still happening, but see we get this nice little object, and it has two functions. It has move, and it has display. So those are the two things that the return statement gives back to the global program. So that way we can organize which things need to be available to the rest of our program and which things are just part of the object. So, yeah.
What's inside the display function?
Yeah, the display function is just the drawing the images. Yeah. And I'll make this, example available so you guys will be able to work with this. So if I take stuff out of return, if I just put move here, you'll see that my player object is just that move function. So I can decide which functions are available to the main program by putting them in this return statement at the bottom. So now that we've got move and display, we can actually call this from our draw function. So now I can say player.display. So to access one of our functions that's inside of another function, or inside of our object, this is called a method. So this is calling a method from an object. So the functions inside of objects are referred to as methods. You can also just call them functions. It means the same thing. So when we call a method from an object, we use a dot. So we say the object and then the method. The reason that player, so the player with the lowercase p is like the instance of the object. It's sort of like the clone. Player with a capital P is the definition of the object. That's kind of the blueprint for the object. So I'll put a note here. Lowercase player is the instance or clone or the thing that we, the thing that we make. Capital player is the blueprint for the object. Okay, so now when we say player.display, this will display the player. But my key presses don't do anything yet because I haven't called the move method. So before we call display, let's say player.move. Okay, so now we've recreated our functionality, but in our main program, this looks really nice, right? It's starting to look more like a function that has lots of parts because we have this one thing called player. It knows how to move and it knows how to be displayed. And then we can start to add other parts. So what we're going to do now is make a bird object. And the bird object is going to be almost exactly the same. The difference is going to be how does the bird object move. The movement of the bird object is not going to be controlled by the user. It's just going to be programmed. So we'll be able to change the way the move function works for the bird inside the bird object. So we're going to do that now. Any questions before we add in the bird object? Okay. So we're going to do something very similar. I'm going to add my bird images first so that we have something to display. So I'm going to open up my file system. I have my character sprites, but I need my bird sprites. So let's go to Piskel, and I'm gonna load up my bird art. So I'm gonna go into my art folder and find my bird. Let's see, which one is more recent? This one's more recent. So I'm gonna throw this in here. And then, so I have two animations for the bird. One is the bird flying, and the other is the bird kind of disappearing. So remember, when I export the animated GIF, I want to choose the frames that I want to export. So I'm just going to delete the disappearing frames. And so I just have the little bird flapping animation. So I'm going to go to export. I'm going to scale this up to 2, and then download the animated GIF. Now I'm going to undo and delete these first 2 frames. And now I have the bird disappearing animation. So I'm going to do the same thing. I'm just going to download an animated GIF. And actually, let's add a blank frame at the end. I think that'll look a little nicer. It might not be necessary, but I think it'll look nicer in the short term. Okay, so let's download that. So now we've got our 2 animated GIFs in the Finder. I'm going to open up a new window and go to the Downloads folder. So we've got the bird flapping. So I'll rename this bird flying. And then this animated GIF looks kind of goofy. Let me try that again. I wonder if I somehow... Oh, I forgot. Yeah. The Mac preview of the GIFs is not great. So don't necessarily look at that. I don't know why it looks so weird, but if I open this up in Chrome, it looks more like what I would expect it to. So I think the Mac preview is kind of off for some reason. Anyway, I'm going to rename this bird eaten. So I've got 2 animations for the bird. And I'm going to upload these to my P5 sketch. So I'm going to go back to P5, go to my sprites folder, and click the drop down and upload. And then I'm just going to select both of those GIF files. These should be pretty small. This one is 6 kilobytes, and this one's 5 kilobytes. This one doesn't seem to want to go. I'm going to save and reload the sketch and see if it's there. No. Okay. That's okay. I'm going to try it again. I'm going to upload the file and upload bird eaten. Okay, there we go. Sometimes the P5 editor, maybe the backend timed out or something. Okay, so we've got our 2 GIFs here. And just like we did with our player sprites, we need to load our bird sprites. Okay, it looks like it's having a hard time loading. Okay, there we go. All right. I'm just going to put these on another line just to keep them organized. So I have bird flying sprite and bird eaten sprite. And then you can just copy and paste these lines if you want, but we just need to load these sprites into the browser memory. So I have the bird flying sprite and the bird eaten sprite, just copying and pasting these variables into the preload function. And then make sure to use the right paths here for these animated GIFs. So this one is bird underscore flying. And this one is bird underscore eaten. Okay. So now we've got our bird sprites. So now let's design our bird object. So the bird object is pretty similar to the player object. The main difference is instead of moving according to key presses, it's going to move just down the canvas. Some of you guys program different movement for your objects in Scratch, so you could try programming that in P5 as well. I'm going to go over just a really basic setup, but we could talk about other setups that you could do. And then it also needs to be displayed, which is going to look very similar. It's going to display the flying animation if it's flying, and if it gets eaten, we'll display the eaten animation. But we're actually not going to get to the eaten part today. We're going to do that next time. Okay, so let's collapse some stuff. Just going to collapse all of my other functions and create the bird object. So under the player, I'm going to make a function bird. And we'll add all the stuff that the bird needs, but we may make some changes depending on how the bird is going to behave. So the bird does need an X value. So the bird needs a place where it starts on the canvas position, but we're actually going to randomize the X value of the bird. Remember in Scratch, we kind of randomize where the bird appears at the beginning. We don't quite know how to, we haven't covered that yet. So we can just go over it now. So I want an X value. I want it to be random. So I'm going to use a random function. And in P5, if we look up random, there's a random function built into P5, which is pretty useful. It basically just takes two numbers and it gives you a random point in between. So this is actually an example that's very similar to what we're about to do. It says X is random with the minimum of 0 and a maximum of 100. And Y is also random with a minimum of 0, maximum of 100. So when I run this sketch, this dot goes to a different place each time. So that's pretty useful. So we can just use something like that. So say X is random. We'll start at 0, and then we'll use the width of the canvas. So the width of the canvas is 400. I can also use a built-in variable that P5 creates after the canvas is created, which is just width. This is just the width of the whole canvas. So that'll make it a little bit easier. If I decide to change the width of the canvas at some point, I don't have to change that number. So I'll say bird has a random starting position. Okay, so the bird also starts at the top of the canvas. So to get that, I just want let y equals 0. I'm hearing a little bit of my own voice. If somebody's watching a video where I'm talking, could you either use headphones or turn it down a little bit? Thank you. Okay, so the bird has a random starting position on the x-axis, but it starts at the top of the canvas on the y-axis. So top of canvas is just y equals 0. So then the bird has an animation state. So we'll say let animation state equals 0. And we'll say 0 is idle and 1 is eaten. If we need other states later, we can add them. Okay, so now we have our move and our display functions. So we're going to have function move. So this is where we define how the bird moves. And then we have function display. This is where we define which animation we want to display. And then just like our player, we're going to return both of these functions. So how do we want the bird to move? Just like in P5, we just want the bird to travel down the screen. And for now, we're just going to make this very simple. Later, we'll update this a little bit. So for move, we're just going to say y minus equals 5. This is the same thing as saying y equals y minus 5. This is kind of like, we kind of covered this with the player movement, but this is like in Scratch when we have motion and we say change x by or change y by. We're taking the current value of y and we're subtracting 5. But actually 5 is going to go the wrong direction because y starts at 0 and it goes down. So we need to actually add 5. So we're just going to move the bird down the screen for now. We'll make it a little bit more interesting shortly. Then for display, for now, we're not going to have an eaten state quite yet, but we are going to add one eventually. So we're just going to add the first part, if animation state. Remember, double equals 0 for our condition, for our if statement. So we're using the image function again, and we're going to draw the bird flying sprite. So I'll copy that and paste that in there. And then I'll put in X and Y. So again, the bird has its own X, its own Y. It has its own animation state. All of this code is completely legit, even though it's repeating what the player has, because it's contained within the scope of this function. So those X and Ys only describe the X and Ys for that object. Okay, so let's make a bird, and then we will make a couple updates to how the bird works. There's a lot that we still need to do to add multiple birds and do other stuff like that. We're not quite there yet, but we will be soon when we add stuff next week. Okay. So for my bird, I'm going to make a bird variable. And actually, let's make a couple birds. So let's just start with bird 1. We are going to run into an error with our bird if we try to create it in the global scope. You may run into this, so I'll show you what it looks like. So if I try to make a bird like I made the player, and I run this, I'm going to get an error. It says random is not defined. So the reason I'm getting this error is when I create a bird, it's going to run all the code in the bird function. And one of the pieces of code I'm using, this random here, is a P5 function. It doesn't exist in the global scope. It only exists inside of another P5 function. So that's a little tricky thing with P5. We need to create the birds in either setup or draw for them to be able to reference the rest of our P5 code. So if we want to use that random here, we're gonna run into an issue there. When we change the program next week, that's not going to be an issue anymore. But what we can do is just say we want a bird here, and then we can just say what the bird is in setup. So we can say bird1 equals bird. This is going to make it so that we don't have that error. Okay, we don't see the bird yet, so let's do that. So in our draw function, now we have player move, player display. Now let's say bird1.move and bird1.display. Okay, so now we've got our little bird going. We only have one, so let's add 2 just so we can see that one of the main points of making an object is so you can have multiple copies of something. So if I make bird2, I'll say bird2 equals bird. And then we'll just copy all of this and put bird2 move, bird2 display. So you can see I get these 2 random birds whenever I run my code. And they're going at the same speed. I could randomize the speed. That might be a nice thing to add. But yeah, let's add 2 more things, and then we'll do workshop time. Just because I don't want to add too much stuff. So this is what makes the bird move. So let's change the bird movement a little bit. We'll probably modify this a little bit next week, but let's just change it now so it runs a little bit more, does a little bit more interesting stuff. So let's make a speed that we can randomize. So let's make a value inside the bird called speed. And let's set it to something random between, we used 5. So let's set it to something between like 2 and 8. So the bird will be, some birds will be really slow, some birds will be very fast. So instead of increasing by 5, I'll increase by speed. So this will have a random value. So speed will be somewhere between 2 and 8. And so now the bird will move much faster. Or possibly slower. And so the birds also move at different rates from each other. So then let's also reset the bird, and then this is the last thing we'll do. Just for now, we'll say if y is greater than height. So what this is saying is if the y value of the bird, which is constantly being added to, if it's greater than height, height is the total height of the canvas. So if the y value of the bird is greater than the height of the canvas, that means it's disappeared from the canvas. So if that happens, let's just set it back to 0. So now these birds will appear again. And while we're at it, why don't we randomize the x again? So I'm just going to copy x equals random 0 to width. So we'll change the x value. And we might as well change the speed too. We're going to probably replace most of this section later. So I'll just put a note here. Reset the bird when it hits the bottom of the canvas. So now we've got a lot more functionality. We still don't have the bird interacting with the player. That's something that we'll add next week. We'll also add sounds next week. So we'll add a couple features that way. And yeah, we'll start getting closer to something that works like a game. So yeah, that's it for today. So the object design is probably going to be a little tricky at first because the code is a lot more complex now that we have functions that are inside of functions. The main goal for today is just to add in your animated GIFs into your sketch. Once you get done with that, if you want to change things that are happening in the code, you might want to play with the movement of the character or the birds. If you want to, go over different ways to do that, we could talk about ways to make that specific to what you want for your game. But the main thing is just to kind of get the objects implemented. Okay, I will stop the video here.